Welcome to a lesson on Pythagoras Theorem. The formula is c squared equals a squared plus b squared. Note that this formula only works for right-angled triangles. On the right is a right-angled triangle. The sides have been labelled. A and B are the legs of the right-angled triangle, and C is the hypotenuse of the right-angled triangle. The hypotenuse is also the longest side of a right-angled triangle. It is also important to note that the longest side C is by itself on the left side of the equation. Now let's do our first example and see the equation in action. With our first example, we have a right-angled triangle. We're given two sides, 4.2 and 5.6, and we need to find the length of AC. I'm going to label the side AC as X. It is also important to check that this is a right-angled triangle, which means we can use Pythagoras Theorem. The formula is c squared equals a squared plus b squared. Now we're going to substitute in the length of each of the sides. Note that because x is the longest side of the right-angled triangle, that will be our c. Now we'll use our calculator to work out the values of 4.2 squared and 5.6 squared. 4.2 squared is equal to 17.64 and 5.6 squared is equal to 31.36. If we add those up, we get 49. In order to find x, we need to square root both sides of the equation. So we get square root of 49, which is equal to 7. Therefore, the length of AC is 7. And now we're done our first example. Let's go down and do another example. This second example looks a little bit more complicated than the first example, but I think we can do it if we do it step by step. Let's look at the question. They ask us to calculate the length of AB. There's an extra word here, so I'm just going to get rid of it. Let's highlight the length we're trying to find. The length AB is part of triangle ABC, which is a right-angled triangle. However, we only have one other length, which is the 9.5. We can only use Pythagoras if we know two of the lengths, so we can't use it yet to find the length of AB. If we look carefully, we also notice another right-angled triangle, triangle ACD. It is also a right-angled triangle, and we have two of the sides of the triangle. So we can find AC first, before finding the length of AB. I'm going to label AC as X and AB as Y. In order to find X, I'm going to use Pythagoras Theorem. C squared equals A squared plus B squared. Because X is the longest side of the right-angled triangle, I'm going to plug that in as C. X squared equals 7 squared plus 4 squared. Also note that the 7 and 4 are interchangeable because 7 squared plus 4 squared is the same as 4 squared plus 7 squared. 7 squared is 49 and 4 squared is 16. So now we get x squared equals to 65. If we square root both sides, then we get x equals to square root of 65. And now I'm going to plug that into the diagram. X is square root of 65. Now we can use Pythagoras again in order to find y. Once again, c squared is equal to a squared plus b squared. Now it's important to note that 9.5 is the longest side of that right-angled triangle. So 9.5 will be our c. So we have 9.5 squared is equal to y squared plus root 65 squared. Now if we use our calculator, 9.5 squared is equal to 90.25. which is equal to y squared plus 65, because the square root of 65 squared, the square root and the square cancel out, so it's just 65. Now if we minus 65 to both sides of the equation, we get 25.25 is equal to y squared. Now if we square root both sides of the equation, we get y is equal to the square root of 25.25, which is 5.0249. If we round it to 3 significant figures, then we get 5.02. Therefore, the length of AB is 5.02. And now we're done with our second example. On the next page, I have 3 exercises for you to do. I'm going to pause on each exercise so you can see the question. Here's exercise 1. Here's exercise 2. And here's exercise 3. I hope this lesson on Pythagoras Theorem was useful for you.